Subsequent theories on the behavior of light would even more improve this idea, which included French physicist Louis Victor de Broglie calculating the wavelength at which light operated. This was followed by Heisenberg's uncertainty principle, which specified that measuring the position of a photon properly would interrupt measurements of its momentum and vice versa, and Schrödinger's paradox that claimed that all particles have a wave function. At some area, the measurement of the wave function will arbitrarily collapse, or rather, decohere, to a greatly peaked function. This was shown in Schrödinger popular paradox, including a closed box, a feline, and a vial of toxin, called the Schrödinger's cat paradox. According to his theory, wave function also progresses according to a differential formula, aka for particles with mass, this equation has solutions, but for particles without any mass, no service existed. More experiments involving the double-slit experiment verified the double nature of photons, where measuring devices were integrated to observe the photons as they went through the slits. When this was done, the photons appeared in the type of particles and their effect on the screen corresponded to the slit's small particle-sized areas dispersed in straight vertical lines. As anticipated by Schrödinger, this might just be fixed by claiming that light has a wave function, which observing it causes the variety of behavioral possibilities to collapse to the point where its behavior ends up being foreseeable. The advancement of quantum field theory (QFT) was designed in the following decades to resolve much of the ambiguity around wave-particle duality. Today, photons belong to the standard design of particle physics, where they are categorized as boson, a class of subatomic particles that are force providers and have no mass. So how does light take a trip? Basically, taking a trip at incredible speeds, 299,792,458 meters per second, and at various wavelengths, depending upon its energy. It has no mass, however can still be soaked up, reflected, or refracted if it can be found in contact with a medium. And in the end, the only thing that can really decrease or apprehend the speed of light is gravity, i.e. a great void. What we have actually discovered, light and electromagnetism, has been intrinsic to the transformation which took place in physics in the early 20th century, a revolution that we have been coming to grips with since. Thanks for watching. Please subscribe.